Okay, so in this video we're going to look at nucleophilic substitution. This is one of the reactions of halogenoalkanes. It's the main one for halogenoalkanes. So the important thing to remember about halogenoalkanes is the structure, because that really defines how they react. So the halogen, in this case the chlorine, is always more delta negative. It's always the delta negative part here, because it's more electronegative than the carbon. So this is a polar bond, the delta negative chlorine, delta positive carbon, okay? Because of the difference in electronegativities. This is electron deficient. So we've got an area then of electron deficiency, and that is going to attract nucleophiles. So this is one of the most important things to remember about halogenoalkanes. The electronegative chlorine being delta negative, the delta positive carbon. Okay? So what is a nucleophile? Nucleophile is an atom or a group of atoms which are attracted to an electron deficient area, as in the carbon here, and when they get there they donate a pair of electrons, so an electron pair donor. And when they do that they form a new covalent bond. So here's some examples. We've got water, hydroxide ions, ammonia. All these three here can donate a pair of electrons, so that's really important to remember. Okay? So let's have a look at an example of a nucleophilic substitution, and the common one which you need to know about is the hydrolysis. So hydrolysis is when we're swapping that halogen for a hydroxide group. Okay? So hydrolysis is an example of a nucleophilic substitution reaction. Here's an overall equation for it. So you've got your halogenoalkane, here again it's chloromethane in aqueous conditions. We add sodium hydroxide, aqueous sodium hydroxide, and we reflux it. So we're heating it up, and when that occurs we make an alcohol. Here we made methanol. So we're swapping the chlorine for the OH group here. And then that chlorine comes off and it's in solution with the sodium ions, which were from here before, to make sodium chloride solution. Okay? So you need to know those conditions. Let's have a look at how the reaction actually occurs, the mechanism of the reaction. So we've got our delta positive carbon that attracts a nucleophile, or a nucleophile, in this case it's hydroxide ions. When they come in contact with the chloromethane or any halogenoalkane, they donate the lone pair of electrons from the oxygen of the hydroxide ions to the delta positive carbon. Okay? Not just any carbon, it's got to be the delta positive one. So when you draw it out, you must show the dipoles, so they really explain how this mechanism works. So as these pair of electrons are being donated, it forms a new covalent bond, but carbon can only form 4 covalent bonds, so it's got to break one of the old ones. So the chlorine bond here is broken, and that leaves then, and you form the chloride ion. So that chlorine is leaving, and you get the chloride ion, and the hydroxide group is joined on, and you made the alcohol. Okay, so it's all in one step there, making this substance here, and that's nucleophilic substitution. So things to remember to put on is the curly arrow from the lone pair to the delta positive carbon, dipoles from the bond to the chlorine. Okay, thank you.